39, 40, 41, 42, and 43. So let's start with 39. So 39 is a sailboat with a mass of 200 kilograms. So mass equals 2.0 times 10 to the third. 2,000 kilograms. Alright, experience a tidal force. So the force of the tide is 3.00 times 10 to the third newtons, directed to the east. And a wind force, so force of the wind, is equal to 6.00 times 10 to the third newtons northwest at 45 degrees. We'll have to draw that picture to see that. North of the west. What is the magnitude of the resultant acceleration? Ooh, fun. Acceleration equals what? Alright, so we've got beautiful little sailboat. Alright, sailboat. So we've got our sailboat that is going to have some force vectors on it. 2, 3. So remember throws. So we've got mass is 2,000. 2. Kilograms, and force weight is 3,000 newtons. Yes, baby. East. So this is the force of the tide. 3,000 newtons. And then the force of the wind, 6,000 newtons. North of west, 45 degrees. North of west, which puts this 45 degrees. And this force of wind is 6,000 newtons. All right. Now I'm going to look over the problem, make sure I didn't miss anything. Alright, so we first need to find what is the resultant force. So we are going to resolve these guys down, add them together. So resolving that guy, I'm going to use another color here. We are going to have the force of the wind in the x and the force of the wind in the y. Okay, force of wind in the x is going to be your adjacent. Remember SOHCAHTOA. Alright, cosine of 45 degrees, which you probably already know, is equal to the adjacent, which is force of the wind in the x. Well, that's tricky there. And 6,000 newtons on my bottom. So what is that? 0.5 cosine of 45? I always forget these. Oh, close, but no. Times 6,000. So I get my force of the wind in the x is 4,000. I'm going to keep all my digits. My instinct is to use sig figs, but the textbook is not doing that, so I don't want us to get all off with the answer key after all these. Okay, so I'm just recording everything I see in my calculator for now, and I'll do my sig figs at the end. So that is my force weight in the x. I can find my force weight in the y by doing the sine of 45 degrees is equal to force weight in the y over 6,000 newtons. So sine 45 times 6,000. That's why 45 is special, is because it's the same. Dun, dun, duh. Clearly my brain is not asleep here. I accidentally touched the little thing on the side there. Okay. So we've got our force weight in the y, our force wind in the y, force wind in the x, and we are going to add it to our force tension. So I'm just going to do like a total sum of my forces here. So we've got the force of the tide is 3,000 newtons. And I'm going to change color for the other guys. And then I've got my force of the wind in the x, which will be a negative 4,242 point yada 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 640,687 newtons. Okay, and then the only force that's in the y is going to be this small one here, also 4,242.640687 newtons. There's the wind in the y. Okay, so we're going to take 3,000 minus 4,242.640687. And so my net force in the x is going to be a negative 1,242.640687 newtons. And this force into the y, 4,242.640687 newtons. And this again is the force of the tide. Well, we'll call this the net force in the x. Force in the x. Alright. We have the summation of the force, and we've got this. So what we're going to do is we're going to add these vectors together. I've already got them set up tail to tail, so I'm going to just show you parallelogram method, because you can hopefully at this point remember that we're just going to use the Pythagorean theorem and find this resultant angle. If we have A and B for the Pythagorean theorem, we can find the C. So we're going to square force wind in the y and square that one, and then add them together and find the square root. So I'm just going to type it on my calculator because I don't want to spell this out. And this is the resultant force that I'm looking for. So 1,242.640,687 squared plus 4,242.640,687 squared. Square root of that will give me a resultant force of 4,420 That's with 3 sig figs, so that's why I rounded off that way. And newtons. And then we can figure out the angle. Does it want the angle? We can do it for fun if we really want. Knowing that if this is our angle we're looking for right here, our adjacent and our opposite. So inverse tangent of our opposite for 242.640687 divided by, I'm not putting a negative sign in because it's just going to tell me the negative angle. I just want to know what it is. And I can apply it to what I know about it. So 1242. Yeah, okay. So I get 73.7 degrees. That's a lot bigger than I drew in my picture. Let's look at it conceptually though. This being bigger than this number being much bigger than this one, that makes sense. All right. That is my resultant force. Now, the acceleration is what we're actually looking for. So if my resultant net force is this, I am going to set my net force equal to mass times acceleration. So 4,420 newtons is equal to mass. They told us was 2,000 kilograms. Alright, so we get acceleration. So 4420 divided by 2,000. 2.21 meters per second squared. And the answer key says 2.2, so I'm going to go back and check to see, oh, crud buckets. Yeah, they gave you the mass in 2 sig figs, so that's why it's 2.2. Bingo. That was the answer to 39.